Touch receptors in the skin. A vast network of touch receptors and nerve endings in the skin make up the somatosensory system. This system regulates all types of sensations on the skin, including touch, temperature, pressure, pain, vibration, etc. Somatosensory system includes different receptors that are mechanoreceptors, pain receptors, thermoreceptors, and proprioceptors. Types of touch receptors. Mechanoreceptors are the touch receptors. These mechanoreceptors sense the stimulus due to anatomical distortion of their cell membranes. Mechanically gated ion channels sense this distortion and their gates close or open in response to the stimuli. Thus, an impulse is generated in the neurons due to the ion exchange that travels to the central nervous system. Touch receptors include the following types. Merkel's discs. These receptors are found in both hairy and non-hairy skin. They are found in the upper layers of skin near the base of the dermis. Merkel's discs are most abundant in the lips and fingertips. They have unencapsulated nerve endings that respond to light touch. These receptors are slow adapting receptors and come into use in works such as typing a keyboard. Meissner's corpuscles. These receptors are more often present in non-hairy skin, also known as glabrous skin, such as eyelids and fingertips. The primary function of these receptors is to sense fine pressure and touch, but they can also sense flutter or vibrations. They are rapid adapting receptors with encapsulated neurons and can respond to fine details. Ruffini endings. These are also called bulbous corpuscles, found near the base and deeper in the dermis layers. These receptors have encapsulated nerve endings that are found in both hairy and glabrous skin. Ruffini endings adapt slowly and detect any distortion in joints and skin stretch. They also have a role in finger movements and gripping different objects. Pacinian corpuscles. These receptors are structurally similar to Meissner corpuscles, present in both hairy and glabrous skin. These receptors adapt rapidly and sense high-frequency vibrations and transient deep pressure. Pacinian corpuscles are found in the pancreas, bone periosteum, genitals, breast, and joint capsules. These receptors detect stimulus by being compressed that excite external dendrites. How do we perceive touch? From skin to brain. The mechanoreceptors are attached to different types of nerve fibers. They include A beta, A delta, and slower C fiber groups. The most common nerve fibers group is an A beta fiber that transmits impulses rapidly. A delta and C fibers carry impulses from root hair plexuses and free nerve endings. The receptors for fine touch and pressure have narrow receptive fields and are exceptionally delicate. As a result, they provide complete information about the source of stimulus, including size, location, shape, and movement. Sensations of fine touch and pressure receive the brain via the spine and posterior column pathway. After they reach the brain, a person becomes conscious of the stimulus. Other receptors that perceive crude touch and pressure have broad receptive fields. They are able to sense the stimulus from a large area of skin. But a person is unable to define the precise location of the stimulus and other detailed information. These sensations reach the brain via the spine and anterior spinothalamic pathway. In the brain, all the touch sensations coming from different parts of the body are incorporated and processed by the primary sensory cortex. All the signals or impulses are differentiated on the basis of the nature of the receptors. Each cell group in the cortex has deeper columnar structures responsible for touch. As the impulse moves deeper into the cortex, it becomes more precise, and the brain is able to get detailed information. Touch perception is also called haptic perception because we are able to sense the surrounding environment around us due to this perception. Haptic perception incorporates the somatosensory information via touch that cannot be acquired from viewing the object or proprioception.